All right, hello everyone. Here I have some slides for us to get started with Standard 5 on normal distributions. Today we're going to be talking about the empirical rule for the normal distribution, otherwise called the 3 sigma rule or the 68, 95, 99.7% rule. You can see, for some review here, that a normal distribution is both symmetric and unimodal, where I have a centered mound of data and the outliers are symmetric on the left and the right. The 68, 95, 99.7% rule states that 68% of the data lies within one standard deviation from the mean. So whether it's one standard deviation below or one standard deviation above, that encapsulates 68% of the data. If I go to Desmos here and show you this, here's that same normal distribution graphed on Desmos using the key phrase normal dist. If I have a minimum standard deviation of -1, indicating one standard deviation below the mean, and a maximum of +1, indicating one standard deviation above the mean, this region right here shaded in red accounts for 68% of the area under the normal curve. Or in other words, 68% of all data lies within one standard deviation of the mean, given the normal distribution. If I extend that further, within 2 standard deviations of the mean lies even more, 95% of the data. Given a normal distribution, within 2 standard deviation lies 95% of the data. So looking at here on Desmos, I can see that if I extend it out further into the tails to 2 standard deviations, either above or below the mean, now I've got 95% of the distribution. 95% of all data is within 2 standard deviations of the mean, given a normal curve. And then lastly, within 3 standard deviations, that's almost everything. Anything outside of 3 standard deviations is probably considered an outlier for the data. So within 3 standard deviations of the mean lies 99.7% of the data, approximately. So if I extend this to negative 3 to +3, it's about 99.7% of the entire curve. I've just about got the entire thing. There's just a slight bit left over in either tail on the left and the right sides, both above and below 3 standard deviations from the mean. All right, so let's answer a few questions based off this empirical rule, 68, 95, 99.7%. And the best advice I can give people when doing a normal distribution is to draw a picture, draw a picture. So for this first question here, what percent of data falls more than 2 standard deviations below the mean? So let's draw a picture. So 2 standard deviations. Here's -2, 2 standard deviations below. Here's +2, 2 standard deviations above. Within that range is 95% of the data, which means that the 2 tails account for 5%. Since I only want the part that's more than 2 standard deviations below the mean, that means that all we're looking for is one of the 2 tails. Since the normal distribution is symmetric, it would be half of the 5% that's left over in the 2 tails. So for our final answer, half of 5%, or 2.5%. For question 2, what percent of data falls less than 1 standard deviation above the mean? Less than 1 standard deviation above the mean. So once again, let's draw a picture. There's our normal distribution. We'll be within 1 standard deviation of the mean. And once again, this accounts for 68% of the data. Now, I only want what's less than 1 standard deviation above the mean. So that would be the part from 0 up to +1. less than one standard deviation above the mean. It has to be above the mean and no more than one standard deviation from the mean. So this area that's shaded in green between 0 and 1 standard deviation above the mean. Well, if within one standard deviation lies 68%, one standard deviation above would be half of that. Half of 68%, or 34% for our final answer. We're just kind of slicing and dicing the 68, 95, 99.7% empirical rule. A couple more questions based off of that. What percent of data is within 3 standard deviations of the mean? So once again, we'll draw another picture. Here's our normal distribution with a symmetric unimodal normal curve. So within 3 standard deviations from the mean means that I'm going to capture almost everything. 99.7%. So what is within that? Well, that's exactly what we have right here. Within 1 standard deviation, I'm sorry, within 3 standard deviations of the mean would be the region I've just got outlined. Pretty much everything under this normal curve. So that would be, for our final answer, 99.7%. Almost the entire model. Anything outside 3 standard deviations, the remaining 0.3% will be considered an outlier, an atypical data point. All right, last one of these on the 68, 95, 99.7% empirical rule. What percent of 1 and 2 standard deviations? This is going to be a little bit more tricky because now we're talking about between rather than either within or outside of the 1, 2, or 3 standard deviations from the mean. So of course, we'll begin by drawing a picture. And labeling some standard deviations. All right, so let's get a few things put together here. I know that within 1 standard deviation lies 68% of the data. Within 2 standard deviations would lie 95% of the data. Now this says what percent of data is between 1 and 2 standard deviations from the mean. So that could be either above or below this part here, as well as this part here. Which means that I want the full 95%. I want this entire part, but not what's in the middle, not the 68%. So that would be everything that's within 2 standard deviations, but not the part that's within 1 standard deviation. So more specifically, 95 minus 68. 95 minus 68 should be 27%. (27% falls within 1 and 2 standard deviations from the mean. Between 1 and 2 standard deviations from the mean. All right, let's put this in more of a applicable context. Heights of males in inches are given by the model n71,3. That means they follow a normal distribution where the average is 71 and a standard deviation is worth 3 inches. So in part A, we're going to draw that picture. put the middle at 71. And every standard deviation, I'm going to either add or take away 3 inches. So 74, 77, and 80. Now I'm going to do 3 standard deviations below the mean and take away 3 inches here. So 71 minus 3 would be 68, 65, 62. And we'll draw the normal curve. We can do the same thing on Desmos, but I'm going to, instead of doing just the default mean of 0 and standard deviation of 1, let's do 71, comma 3. Hit the magnifying glass, and here is our picture we just drew by hand a second ago. Height is at 71. As I move down the curve, adding on 3 inches for each standard deviation to the left and to the right. All right, so for part B, it says, in what interval would you expect the central 95% of male heights to be found? Well, the center 95% would be within 2 standard deviations from the mean. Namely, from here, 65 inches, to here, 77 inches. Now I've got the picture, let's use it. Counting 2 standard deviations below the mean, 1, 2, and 2 standard deviations above the mean, 1, 2. That gets me between 68 and 95. I'm sorry, between 65 and 77 inches. What percent of males are shorter than 74 inches? So 74 inches is 1 standard deviation above the mean. So what's everything here? Less than 74 inches. Now keep in mind, between 1 standard deviation, from 68 to 74, that would be the 68%. Which means that in either tail, I have the remaining 32%. So on either side, half of 32 makes 16. So less than 74 is the 68 plus the 16. Everything but the 16% above 74 inches. So 68 and 16 add up to 84%. For letter D, what percent of males are taller than 77 inches? So if I mark off 77 inches, that would be here. Within 2 standard deviations lies 95% of the data, which means that the 2 tails account for the other 5%. So 2.5% below and above the 2 standard deviations from the mean. Taller than 77 inches would be the other 2.5% left over in the right tail. Okay, and then lastly, letter E. What height would you consider unusually short for a male? So unusually short would be an outlier on the low side. Anything that would be more than 3 standard deviations below the mean. So I'd probably say a height that would be less than 62 inches or 5'2". A unusually short height for a male is less than 3 standard deviations below the mean or 62 shorter than 62 inches, which is 5'2". Anything that would be either more than 3 standard deviations below or 3 standard deviations above is considered an outlier for a normal distribution. Since I want something that is unusually short for the male, let's look at 3 standard deviations below the mean, which would be anything less than 62 inches, anything smaller than 5'2" for a male. That's a little bit of practice problems and some information on the 68, 95, 99.7% rule. We'll see you again next time.